Okay, so this is the first video lesson, right? I'll be using both this video format and the previous format we have been using because the stretch is not easy. I get it. Okay, new members welcome. Make sure you buy 80 leaf short notes. Buy 4 of them, 1 note for each of them. I get it, 1 note for each of them. So do it so that you can using those notes for writing. I get it. It's very important. Make sure before you start watching this video, make sure you are with your writing materials. I get it. Okay, so this we are starting with chemistry. We have done this topic before. We stopped halfway, right? But I'm starting afresh so you can see everything I'll be doing. Okay, so the topic is types of reactions, oxidation and reduction. This is a topic under chemistry, types of reactions, oxidation and reduction. So first, let's see the meaning of reaction. Okay, first let's see the meaning of chemical reaction. Look at the definition. Chemical reactions are changes in which some new substances are formed. The new substances formed are called the products. In a chemical reaction, always new substances are formed. Are you getting it? Let me say the reaction between hydrogen and oxygen. Hydrogen and oxygen will react to form what we call water, isn't it? So the hydrogen and the oxygen are the left side, isn't it? So those reacting substances are what we call the reactants. Are you getting it now? The ones that are reacting are called the reactants. Okay, then the water that is being formed from the reactant is what we call the product. So meaning the reactants are at your left side while the products are at your what? Right side, or in your right side. I know I call it English. So please take note. The reacting substances or the reacting elements or the reacting compounds at your left side are called the products. They are the ones that are reacting. Are you getting it? While the formed compound at your right side is called product. So please take note. Okay, so chemical reactions are changes in which some new substances are formed. So the new substances is what we call the product. New substances are formed when two elements or two compounds are reacting. They must form what we call product. That is what we are calling the new substance. Are you getting it? So in every chemical reaction, new substances must be formed. So take note. Let's go to the second one. So we have different types of reactions in chemistry. Are you getting it? We have different types of reactions in chemistry. So number 1 is combination reaction. You can see them. Number 2 is decomposition, displacement, double decomposition, catalytic reaction, reversible reaction, thermal dissociation, and oxidation and reduction. Make sure you are writing. Okay, so these are the types of reactions we have. So let's start from the first one, which is combination reaction. Let's know the meaning of combination. What is the meaning of combination reaction? Okay, let's know the meaning of combination reaction. So combination reaction, look at it. When two or more substances combine to form one single compound. Combination is just mere English, like it's from the word combine. Are you getting it? Combine, when two things are combining to form one thing. That is what the meaning of combination. Okay, so don't let this English to confuse you. It's just combining two things together. Hydrogen reacts with oxygen to produce water, isn't it? So meaning hydrogen and oxygen are what? Combining to form water. So that is what the meaning of combination. Okay, let me show you something. So look at this ion. Fe is this is ion. Okay, this ion, this is a chemical formula of ion, and S stands for sulfur. Are you getting it? You are a chemistry student, so I believe you have known all these things. So Fe stands for ion, and this S it signifies solid. Okay, meaning iron is solid. Are you getting it? Then sulfur 2, so meaning iron is reacting with sulfur to produce what we call iron sulfide. So are you getting it now? Iron reacts with sulfur to produce iron sulfide. So this is the meaning of combination reaction. Iron is what combining with sulfur to produce this iron sulfide. So are you getting it now? So look at this. So meaning that elements can react with another element to form compound, and also this is called a compound because two elements are what? Two elements reacted to form this compound. Are you getting it? So also elements can react with other elements to form a compound, right? Also compound can react with compound to form bigger compounds. Are you getting it? Look at this place now. Look at it. We have lead 4 oxide. This lead oxide, right? And this one is sulfur 4 oxide, meaning this lead oxide, you can either call it lead oxide or lead oxide anyhow, because this PB stands for lead, LEAD. Okay, some people like they pronounce it lead, but I pronounce it lead. So lead oxide, this is a compound, isn't it? Because two elements are here, lead and oxygen, isn't it? This one too, sulfur and oxygen. Again, so meaning that compounds can react with other compounds to produce bigger compounds. Are you getting it now? So this compound reacts with this compound to produce this bigger compound. So please take note. Okay, so let's continue. Take note of this. Take note of this. The polymerization of ethine is also a combination reaction. This is the ethine C2H2. Okay, C2H2. Let me show you something. As a chemistry student, when you are writing, okay, let me say this is hydrogen, right? This is hydrogen. Hydrogen would have 2 atoms, right? So these two, make sure look at this now. You can see that these two supposed to be at the downside of oxygen. I get it. It because of, right, let me say I type it, okay, I type it, that's why it's in this form. But when you are writing, make sure the number should be at the downside of each molecule or each element. Are you getting it now? So don't write numbers in this form. It is incorrect. I type it in my PC, that's why it's in this form, okay? But when you are writing chemical formulas, make sure your number should be at the downside of each element. So please take note. Is that taken? So the polymerization of ethine is also a combination reaction. So please take note, write it down. The polymerization of ethine is also a combination reaction. Okay, so let's continue. So the second one is what? The second one is decomposition reaction. Okay, this is the second one, decomposition reaction. Let's look at the meaning. Decomposition reaction is a splitting or breaking down of a single compound to 2 or more simpler substances. Okay, decomposition is just when a single compound divides itself, splits itself to form smaller compounds or smaller elements. Are you getting it? You know that this is, let me show you something. This is water, right? H2O is water, isn't it? H2O, don't mind my handwriting. H2O is water, right? So H2O can split to form hydrogen and what? Hydrogen and what? Oxygen, isn't it? So meaning that this compound H2O is what? Splitting, is what? Decomposing to form smaller compounds. So this is the meaning of decomposition. Are you getting it? And this is what the meaning of So let's look at another thing again. Look at it. Look at the downside. It said when heat is needed to bring about decomposition, the reaction is known as thermal decomposition. Okay, when heat is needed, that's why in some this thing, like in some chemical reactions, you will see, let me say, after the reaction you see something in this form. Let me say this is the line. Let me say this is this is H2O. This is H2O. Okay. Oh, Android is no be here. Let's say here this is H2O, this water, right? So in some reactions you will see at the top of each arrow you will see where they write heat. After this video, make sure you cross check your textbook where they write heat, then H2, then hydrogen plus, I'm just citing the example with this chemical reaction. Okay. So I said in some chemical reactions you will see heat at the top side of a particular arrow. So in this type of reaction it is called thermal decomposition. But look at this one. This one there is no heat. This one, a single this thing, compound is decomposing, splitting into smaller elements, right? But if you see it at the top side of the arrow, just know that that is a thermal decomposition. Look at this now. This is a compound. It contains two elements, right? So this compound is splitting to form this smaller element. So are you getting it now? So if heat is involved, it is called thermal decomposition. But if there is no heat, it is just a decomposition reaction. Is that taken? Okay, so let's continue. Let's go to the third one, which is the third one, which is displacement. Oh, let me cancel this. Okay, so the third one is what? Displacement reaction. This is the third one. Let's read it. In displacement, one element or radical replaces another element or radical in a compound. Displacement is from the word replace, just to replace something. Are you getting it? Just to replace something. Are you getting it? So it means radicals. When we talk about radicals have ions. They have charges. Ions are a group of charges, or ions are let me say are compounds which will possess an electric charge. Are you getting it? When we talk about ions, let me show you something. When we talk about ions, like we have oxonium ion. Let me say we have hydrogen ion. You will see, that's why in some these things, let me say hydroxide here, let me use some. In your textbook, I think you have come across this type of this thing, compound. This is a ion because it has charge. This top one, this one is plus. Okay, it's at the top side. Sometimes you will see negative at the top side. I get it. So these are radicals. I get it. These are radicals, combination of two elements. Okay, then it has a charge on top. Charge means is either a positive charge or a negative charge. Okay, any charge. Let me say you can see any charge. I get it. You can see positive or negative charge on top of a radical. So these are called radical. Okay, you will see two elements, then a charge on top, either a positive charge or a negative charge. So meaning that in displacement, one element or a radical can replace another. So let's look at something. Let's read it. Look at it. Ability. Okay, The ability of an element or a radical to displace or replace another is determined by the relative positions in the electrochemical series. Let me explain this. Before a particular element can replace another element in a chemical reaction, it is from the electrochemical series, because we have electropositive elements and less electropositive elements, meaning there are some elements that are more positive. Are you getting it? Why some elements are less positive. Also, there are some elements that are more electronegative, meaning they are negatively charged, while some elements are less electronegative charged. So in a chemical reaction, only the in a chemical reaction, the positive ones, only the positive ones can replace the less positive ones, because the positive ones are more stronger than the less positive ones. All of them are positive, but there are some elements that are more stronger. So are you getting it now? So the more positive ones are the strongest, so they will what? Replace the other ones. Are you getting it now? So in this physical environment, the stronger will what? Beat up the younger ones. Are you getting it now? So in a chemical reaction, the more positive ones are the strongest, so they can replace the other ones. So meaning that those less electropositive ones, they cannot replace the more electropositive ones. So take note. Also, the more electronegative ones can replace the less electronegative ones. Are you getting it now? Okay, let's continue. So the more electropositive ones will replace the less electropositive ones. So I just explained this. So this is just example. Look at the example now. Zinc plus copper sulfide. So copper sulfate, sorry. So you can call it copper tetrahydrosulfate 6. Is in aqueous form. Aqueous form means in liquid form. Are you getting it? In liquid form. So this is solid. Zinc is solid. So look at this now. Zinc has replaced copper. So it is now, it was copper sulfate. It is now zinc sulfate. So you can see that zinc is more electropositive than copper. Are you getting it now? So look at it. Copper is now what? Single now. Are you getting it now? So zinc is more electropositive than copper. So write it down. Zinc is more electropositive than copper. So zinc can displace or replace copper in a chemical reaction. Write it down. Okay, so look at the second one. This is chlorine and this is potassium bromide. Potassium bromide. So chlorine is more electropositive than bromine. This is bromine. Okay, so you can see that here is potassium bromide, but here look at it now. Zinc has replaced see, this middle is not plus, is arrow. Okay, forward arrow. Okay, so make sure you change it. Is forward arrow. Okay, is forward arrow. So chlorine can replace bromine in a chemical reaction because chlorine is more electronegative, not electropositive. Chlorine is more electronegative than bromine, so it can replace bromine in a chemical reaction. I think you have understood this explanation. So let's move forward. Displacement double. Okay, so this is double decomposition. Let me answer this. Okay, so this is double decomposition. I think this one is the fourth or the fifth one. Okay, let's continue. Double decomposition. The reactants decompose to form new substances by an exchange of radicals. I think I've explained the meaning of radicals to you. So the double decomposition, the reactants decompose to form to form new substances by an exchange of radicals. They decompose, meaning they split. Are you getting it? They split, they dissociate. So the two reactants are soluble, and one of the products is soluble while the other is insoluble, volatile, or gaseous. When something is soluble, meaning something that can be dissolved when you put it inside a liquid or under substance. Like example, shock is soluble in water, because if you put shock in water, it will melt. It will what, like it will let me say in form of, but you know what I'm talking about. So meaning when a substance is referred to as a soluble substance, meaning it can melt or it can decompose when added to a particular liquid. Example is shock. If you put shock in water, it will what, melt, isn't it? Or it anyhow. So the reactant decompose to form new substance by an exchange of radicals. So the two reactants are soluble. Jamb might set this question, like they might put the question in this form. Let me say two reactants are soluble. One of the products is one of the product is soluble while the other is insoluble. Volatile means, or insoluble means, something that cannot decompose. Just the opposite of soluble. Soluble can melt when the substance. Soluble means when a substance is added to a liquid, it will what, melt, right? But insoluble means it cannot, because let me say insoluble, let me use let me say examples of insoluble. Let's say gravel. You know gravel now. If you put gravel or stone in water, it will not melt, isn't it? So those are insoluble. Volatile means like in form of, I think is the same thing is with gas. I guess the same thing with gas, they will what, escape. That's why in some chemical reaction gases are used. They can what, escape. They can escape from the chemical reaction. Are you getting it now? So the two reactants are soluble. So look at the example. These are examples of this thing. This is a chemical example, chemical reaction. Silver nitrate and sodium chloride. Are you getting it? He said the reactant decompose to form new substances. So they are what, decompose to form this new substance. Here is silver nitrate. Now it is now silver chloride, because they have exchanged to form new substances. Are you getting it now? They have exchanged themselves to form new substances. So this double decomposition, you know, the first one we did was just decomposition, meaning one single compound decomposing or splitting to form other smaller substances. But this one mark the word double. It is now double, so it will be two. Are you getting that? Supposing it was decomposition alone, this single sodium chloride can split to form smaller ones, but this one is double, so meaning it must have double. Are you getting it now? So if you see this type of reaction, double, a compound, it is what, they are now what, exchanging each other to form new substances. Are you getting it now? Let's move forward. Look at this. Double decomposition reaction is used in the preparation of an insoluble or volatile compound. Write it down. Double decomposition reaction is, so one of the benefits or one of the function of a double decomposition reaction is that it is used in the preparation of an insoluble or volatile compound. I've explained the meaning of insoluble now. Insoluble, something that cannot be melted when added to a liquid or other substances. So please take notes of this. Okay, I think let's continue. Let me cancel this. Okay, so let's continue. Okay, so let's talk about this one. Catalytic reaction. Let's read it. Catalyst. Let's first of all know the meaning of catalyst. Catalyst is a substance which alters the rate of a chemical reaction but itself remains chemically and quantitatively unchanged at the end of the reaction. Know this definition is very important. Know this definition. So Jamb might just bring this question. He said dash is a substance which alters the rate of a chemical reaction but itself remains chemically unchanged at the end of each reaction. It is called what? They will put option catalyst and other things. Okay, so please take note of this definition. A catalyst is a substance, meaning that it will remain unchanged at the end of each reaction. So when we proceed, we understand the full meaning of a catalyst. Okay, so look at the second one. Any type of reaction that use a catalyst is called a catalytic reaction. Are you getting it now? Any type of chemical reaction or any type of reaction that uses a catalyst, it is called a catalytic reaction. Please take note, any type of reaction that uses a catalyst, it is called a catalytic reaction. So we have two types of catalytic reaction. One, homogeneous reaction. Homogeneous, look at it. We have homogeneous and heterogeneous. Let's first of all look the meaning of homogeneous catalyst. Look at it. Under homogeneous catalyst, it means that the reactants, products and the catalyst all are in the same phases. Are you getting it? Meaning homogeneous reaction, it means that the reactants, you know the meaning of reactants already, I've explained it here. The reactant, the product and the catalyst. When we talk about catalyst, in some chemical reactions, you will see, let me draw this. You will see, let me say this is a forward reaction. Are you guys know? This an arrow. Okay, this is an arrow. So when the reactants will be here, right? Why the products will be here, isn't it? So in some chemical reaction, you will see a particular element on top of this arrow. Check your textbook, you will see. So meaning that this element, it can either be element or a compound. So this element or compound that is on top of this arrow, it is called a catalyst. Are you getting it now? It is called a catalyst. They are on top of this arrow in a chemical reaction. When you check your textbook, you will see them. Those elements or compounds that are on top or that is on top of a given arrow, they are called the catalyst. They are called a catalyst. Okay, so meaning that under homogeneous catalyst, the reactants are here. The reactants are here, right? So the reactants, the products and the catalyst are in the same phase, meaning the reactants must be in liquid, also the catalyst must be in liquid form, also the products must be in liquid form. If the reactants are in solid form, then both the catalyst and the product must be in solid form. If the reactants are in liquid form, if the reactants are in gaseous form, all the rest must be in gaseous form, because you must know them, because they will signify them by writing them at the downside. Look at this one, is gas, right? Okay, so they will signify. Look at this one is a gas. Look at, so example, look at these are the reactant, isn't it? So this one is a gas, this one too is a gas, this one too, this one is the catalyst. I didn't do it very well, but it is on top of the arrow, so take note. Okay, and this one, look at the compound that is formed from the combination of these two. Okay, from the combination. Okay, let me just draw it so it won't be confused. So this one is the catalyst, isn't it? This one is now the catalyst. I get it. So both the reactants are in gas, so G means gas. Okay, gas. If it's solid, we see SS. If it's liquid, we see LL. Okay, so both the reactants are in gas. Look at it, the catalyst too is gas and the product too is gas. So meaning this is an example of homogeneous reaction. So this is how to identify homogeneous reactions. Are you getting it now? But if the reactants are in solid or in liquid, all of them, both the catalyst and the products will be in the same, they must be the same. Just take it like that, okay? They must be the same. Then so if you are asked like in Jamb, identify the homogeneous reaction, just look at the downsides, okay? If all of them are the same, if all of them are the same, it can either be gas, it can either be liquid or solid, but they must be the same. If they are the same, just know that that is a homogeneous catalyst. Are you getting it now? But the heterogeneous catalyst is opposite. All of them must be different. Both the reactant, the product and the catalyst must what? They must not be the same. They must be different. Look at it. Look at the reactants now. Look at the reactants. Gas. Look at this thing. Let me cancel this thing so you will understand. Okay. So look at this one now. I'm coming. Okay, so this is the catalyst. Okay, this is the catalyst. This ion is a catalyst. Are you getting it? This ion is a catalyst. Okay, so you can see that the two reactants are gas, but the catalyst is in solid. Are you getting it now? The catalyst which is solid, and the product is also a gas, meaning they are different. One must be different. I get it. So if you check and one is different from the other one, just know that this is a heterogeneous catalyst. So take note, just the opposite of homogeneous. Homogeneous, all of them are the same, but heterogeneous, all of them are what? Different, or some of them, or either one of them must be different. Okay, so I think you have understood this. Let's continue. Okay, I want to tell you this. Look at this. Read it. The formation of margarine from vegetable oil in the presence of a nickel catalyst is also an example of heterogeneous catalyst. So please write it down. It's very important. Okay, the formation of margarine. Margarine is a form of I think you know what you mean of margarine now. Just search it. I think butter form. You know butter. That butter that you are using to do cake, to eat bread. Normal butter. It's in form of butter. So meaning the formation of margarine from vegetable oil. So meaning margarine is formed from all, is produced from all these vegetable oils. I guess me. So if you search, you will see. But I know some of you know the meaning of margarine, like you have seen margarine before, so it's just popular. So meaning that the production of margarine, meaning margarine is formed from vegetable oil. Are you getting it now? So the production of margarine in the presence of nickel. So this is how Jamb we set the question. Are you getting it? This is how Jamb we set the question. They will just write it. The formation of margarine from a vegetable oil. What is used as the catalyst? Are you getting it now? What is used as the catalyst? So note that the catalyst used is what? Nickel. Nickel is the catalyst. Nickel is the catalyst used for the formation or the production of margarine from vegetable oil. So just know them, okay? Know them, okay? The formation of margarine from vegetable oil. What is used as a catalyst? It is called what? Nickel. Nickel is an element. So nickel is the catalyst used in the formation or production of margarine from vegetable oil. So take note. Also, it is an example of heterogeneous catalyst. So take note. Okay, let's continue. Okay, let's see the characteristics. So all these things I'm explaining, they are all Jamb past questions. Are you getting it? Because okay, we draw Jamb past questions. So let's look at the characteristics of a catalyst. Characteristics of a catalyst. A catalyst alters the rate of a chemical reaction, which is number one. Number two, a catalyst remains unchanged in the chemical nature and mass at the end of a reaction. Each feature such as color and texture, however, may be changed. So just take note of all these characteristics, because all these things are jam packed questions. I get it. They will just dash is not, or all are characteristics of a catalyst except, I get it now, or all these are examples, or all these are characteristics or features of a catalyst except. So they will just put like three from here, or yes, it's option A to D. Yes, they just put three from here, then add another one from another option. I get me. So if you don't know these characteristics now, you will just fail the question. I get it. So make sure you know them. A catalyst alters the rate of a chemical reaction. Number two, a catalyst remain unchanged. I've explained before. It remain unchanged. Then a catalyst is specific in nature. It is specific. That is number three. It is specific in nature. A given catalyst will act on only one particular reaction. Okay. Then a catalyst cannot start a reaction. Take note, a catalyst cannot start a reaction. It is effective only in a reaction which is already in progress. It is only a catalyst cannot start a reaction. It is effective in let me say on a reaction that has already started. Are you getting it now? Number five, a catalyst does not affect the type of products formed in a reaction. You know what I mean of product, I've explained before, meaning it does not affect the product or the kind of product that is being formed. A catalyst has no effect on the equilibrium of a reversible reaction. Equilibrium means something that is let me say something that is perfect. It's an equilibrium, like it's not moving backward, it is not moving forward, it is just in one particular place. It has attained equilibrium. Are you getting it now? It has is what attain equilibrium. That's why if you stand something, like if you stand let me say, if you stand shear on the ground, you see that the shear is let me say is very balanced, isn't it? Because the shear is what in equilibrium. It's not moving again, it is not falling. So that is the meaning of equilibrium. So a catalyst will affect the rate of reaction even though it is present in very small amount. So take note, the effect of solid catalyst is improved by increasing its surface area. Take note of this. I want you to take note of this. Take note of this, number 8. The effect of a solid catalyst. A solid catalyst is improved by dash. Jam question. A solid catalyst is improved by A, increasing its surface area. Increasing its surface area is the correct answer. So take note, a solid catalyst is improved by dash A, increasing its surface area. So that is the answer. Okay, a solid catalyst is improved by increasing its surface area. So please take notes. Okay, so let's continue. Okay, look at this. Since a catalyst does not affect the overall reaction, it is written above the arrow in an equation. I've said it before. I said a catalyst is written above and above what? Above the arrow in an equation or in a particular equation. Okay, so any element or compound you see at the top side of a arrow or of a particular arrow in a chemical reaction, just know that that is a catalyst. Okay, that is a catalyst. So from here you will understand more about a catalyst. Are you getting it? So we have a catalyst can be organic or inorganic. It can be inorganic or organic catalyst. Are you getting it? A catalyst may be inorganic or organic catalyst. Let's look. A catalyst may be inorganic. Let's look at the inorganic aspect of catalyst. Catalysts may be inorganic or organic substances. Okay, inorganic catalysts may be grouped into positive and negative catalysts. Take note, inorganic, not organic. Inorganic catalyst may be grouped into positive and negative catalysts, but organic catalysts are known as enzymes and are produced by living cells. You know the meaning of enzyme, right? In biology, we have done enzyme before. Enzyme is an organic catalyst, usually proteinous in nature, which increases the chemical reaction in our body, isn't it? So that is the meaning of, so enzymes are organic. Look at the word now. So that's why they said enzymes are organic catalysts in this place now. Are you getting it now? So enzymes are organic catalysts. So take note. So our main focus is so let's proceed. So positive, look at this. We are starting from here, okay? Positive and negative catalyst. A catalyst which increases the rate of a reaction is a positive catalyst. Are you seeing it now? A catalyst that increases the rate of a reaction. See, just know that the catalyst, the meaning of catalyst is just is a particular, they put catalyst in a chemical reaction to improve its reaction rate. Are you getting it now? Because without a catalyst in a reaction, the reaction will be very slow. The reaction will not attain equilibrium at a shorter time. It will attain equilibrium in a longer time. I get it now. So the addition of a catalyst can increase the reaction rate. So I get it now. So a catalyst in a reaction is very good, or is very important. I get it now. It's very important. So that is just the meaning of catalyst. Catalysts are very important. Catalyst may be element, it may be compound. I get it now. It may be element, it may be compound. So just know that. So in each reaction, all reaction, they have their own catalyst. I get it now. They have their own catalyst. So let's continue. So meaning that a catalyst that increases the rate of a chemical reaction is known as a positive catalyst. So let's look some example of positive catalyst. Look at it. Manganese 4 oxide, which speed up the decomposition of potassium triacylchloride 5. Look at the formula. Potassium triacylchloride 5. I've said before, I said these three, all these numbers are the downside of what? This three is in the downside of oxygen. So take note. So the decomposition of potassium triacylchloride 5, what catalyst is used? Manganese 4 oxide. Manganese 4 oxide. Manganese 4 oxide. Take note to all these catalysts. Make sure you take note, okay? This is a formula of manganese 4 oxide. This MnO2. Okay, so this is the formula of manganese 4 oxide. Are you getting it now? So the decomposition, let me draw this arrow so you see. So make take note of this, okay? The decomposition of potassium triacylchloride 5. The decomposition of potassium triacylchloride 5. What is the catalyst used? The catalyst used is manganese 4 oxide. And manganese 4 oxide is a positive catalyst because it speeds up the decomposition of potassium triacylchloride 5. I get it now. So positive catalyst, they speed up the chemical reaction. So example of a positive catalyst is what? Manganese 4 oxide. So meaning the decomposition of potassium triacylchloride 5, the catalyst used is what? Is manganese 4 oxide. Look at it, manganese 4 oxide. So take note to, okay, let's continue. Let me clean this. Okay, so let's continue. So look at the second one now. We look at the second one. Positive catalysts are important in chemical industry because they can speed up reaction. So you can see it now. This is what a positive catalyst, because a positive catalyst is what important in a chemical industry, because all these chemical industries, all these industries producing soap and other detergent, they use what? Positive catalyst, because it speed up the reacting or the formation process. So let's look at a catalyst which decreases the rate of a chemical reaction is called what? A negative catalyst. So it's just the opposite of positive catalyst. Are you getting it now? Just the opposite of positive catalyst. A positive catalyst increases, while negative catalyst what? Decreases. Are you getting it now? So example of a negative catalyst is tetraoxophosphate 5 acid decreases the rate of decomposition of hydrogen peroxide. Are you getting now? So example of a negative catalyst is what? Tetraoxophosphate 5 acid. Okay, so it decreases the rate of decomposition of hydrogen peroxide, while a 2% of ethanol solution suppresses the oxidation of trichloromethane by air. Okay, so this is the formula. This is the formula: tetraoxophosphate 5 catalyst. Look at it, tetraoxophosphate 5. Okay, so I used to suppress. So make sure you take note. This is an example of a negative catalyst, tetraoxophosphate 5. Okay, so negative catalysts are used to suppress undesirable reactions. That is just it. Okay, they what? Decreases reactions, while positive catalysts, they what? Increases. So example of a positive catalyst, which is what? Magnesium oxide. Negative catalyst example is what? Tetraoxophosphate 5. And so make sure you write everything down. Okay, take note of everything. So in case okay, let me not say anything. Let's continue. Okay, let's learn promoters and inhibitors. Read it. These are not the catalysts themselves, but they influence the rate of a reaction by affecting the efficiency of the catalyst. I guess promoters are not the catalysts themselves. They are not the catalyst, but they are outside. But they are very important in a chemical reaction. Are you getting it? These are not the catalysts themselves, but they influence the rate of a reaction by affecting the efficiency of the catalyst. So example, in the production of ammonia, iron is used as the catalyst. Are you getting it? Write it down. In the production of ammonia, iron is used as the catalyst. Iron, Fe, which is what? Iron. In the production of ammonia, iron is used as the catalyst. This is iron. Iron is used as a catalyst in the production of ammonia. Okay, in the production of ammonia. So let's continue. The catalyst is activated by the addition of trace amount of aluminum oxide or molybdenum. Take note of this aluminum oxide or molybdenum. So in the production of ammonia, iron is used as a catalyst, right? But before this iron, which is the catalyst, can be activated, what is added? They were added either aluminum oxide or molybdenum. You have to read though. You have to read every day. You have to read because things many. Okay, don't be scared. Every day, just keep reading every day. I get me. So aluminum oxide or molybdenum is used as the catalyst. It's used to activate the catalyst, which is the iron, in the production of ammonia. Are you getting it now? So such substances which improve the efficiency of a catalyst are known as promoters. Jamb question. Dash is a substance that improves the efficiency of a catalyst. The function of the promoters is to improve the efficiency of the catalyst. I get it. So Substances which improve the efficiency of a catalyst are called what? Promoters. So take note of the word efficiency. Efficiency. Okay, take note of this word efficiency. I get it. So promoters are used to what? Increase or improve the efficiency of a catalyst. So take note. Why inhibitors? Look at it. Inhibitors or catalyst poisons. You can either call it, another word of inhibitors is called what? Catalyst poisons. So e.g., look at it. These are catalyst poisons or inhibitors. I get it. So look at examples of inhibitors or catalyst poisons. We have hydrogen sulfide, arsenic trioxide, hydrogen cyanide, and mercury salts are catalyst poisons which harm us by inhibiting important enzymes in our body. That's why mercury salt, that's why foods that contain mercury is not that good in our body system. It's not that good. You can see mercury salt. So mercury salt, they have different type of these things, substance. Like under mercury salt we have almost okay, let me just continue, but just know that some food substances that contain mercury is not that good for our system because they inhibit or decreases the this thing, the importance of enzymes in our body, and enzymes are very important. So are you getting it now? Okay, so take note. Let's continue. Okay, let's look at this reversible reaction. That's why in some chemical reactions we see two arrows. One is pointing forward while the other one is pointing backward, isn't it? So this forward one is called the forward reaction, and this backward one is called the backward reaction. Okay, so it means if you see these two arrows in the chemical reaction, it means that this reaction is what? Reversible. It can be reversed. It can come back. Are you getting it now? You know, when two elements are reacting, they will react to form, meaning it is proceeding forward, isn't it? Those two, like hydrogen and oxygen, they react to form water, isn't it? So when it is going forward, it is called forward reaction. When it comes back, it will what? Meaning that two reactants, they react to form the product, isn't it? So those products can react again to form the reactants, which is the reversible or backward reaction. So let's read it. When excess carbon dioxide is passed, take note of this. When excess carbon dioxide is passed through lime water, a milky suspension of insoluble calcium trioxide 4 is formed. I read it again. When carbon dioxide, but just taking on the word excess. Okay, when excess carbon dioxide is passed through lime water. You know lime now here. So when excess carbon dioxide is passed through lime water, what will you see? A milky suspension or a milky color will be formed. I've seen this question for Jamb pass, this thing question papers. So take note of everything I'm teaching you. So when excess carbon dioxide is passed through lime water, a milky color will be formed. Okay, milky suspension of insoluble calcium. The milky solution is the insoluble calcium trioxide 4. Take note of this. Milky suspension is formed, and that milky suspension, it is the insoluble. So I told you, I'll explain the meaning of insoluble. It is insoluble calcium trioxide 4. That milky substance is the same thing as the insoluble calcium trioxide 4. Okay, that is being formed. So this disappears after some time owing to the formation of soluble calcium hydrogen thiocarbonate 4. I get it now. Calcium thiocarbonate 4, it is insoluble, while calcium hydrogen thiocarbonate 4 is soluble. So take note. Okay, so it will disappear after this milky solution has disappeared. This calcium hydrogen thiocarbonate 4 will be what? Formed, and it is what? Soluble. Are you getting it now? So if this clear solution is heated, the reverse reaction will take place and the milkiness will appear. So this is called reversible reaction. I get it now. So the clear solution is a calcium hydrogen thiocarbonate 4, isn't it? But the milky solution is a calcium thiocarbonate 4, isn't it? So meaning that the formed one, which is a product, is the what? Calcium hydrogen thiocarbonate 4, meaning it can react again when it is applied. I get it now. It can react to form the milky solution, which is the insoluble calcium thiocarbonate 4. So meaning it can go forward and come back. So before the product, which is the calcium hydrogen thiocarbonate 4, can react again to form that milky solution, heat must be applied. So meaning that the forward reaction, look at it, in this case the forward reaction, look at it here, let me just draw it for you so you will see it. Okay, so in this case the forward reaction takes place in cold, while the reverse reaction occurs only when it is applied. So I getting it now. The reverse reaction occurs when heat is applied, but the forward one occurs in the cold weather or in the cold reaction. So just take note, the forward reaction occurs in the cold way, while the reverse reaction occurs in the what? Heated way. Okay, it must be applied to form the reverse reaction. Are you getting it now? So let's move forward. If one or more products are removed from the reaction, reverse reaction cannot take place. The reaction is referred to as irreversible reaction, but the fourth reaction will go to completion. Because when a reaction is taking place, when the products are formed, because those products can react to form the reactants again. Are you getting it? And that is called what? That is reversible reaction. It can be reversed. I getting it. But in a situation where one of the products is removed from the reaction, because you know that when those products are formed, they must combine like the same way that the reactants are combining. I getting it. So those products will combine together to form the reactants again. But in a situation where those products, where one of them is being removed from the solution, what will happen? It cannot come back again, because if two products are formed and one of them is being removed, then how will that remaining product form react again? It cannot react again, because it needs another product to react with it to form the reactant. Are you getting it now? So in a situation where one product is being removed from the solution, the reaction cannot form the reactants again. So that type of reaction is called what? Irreversible reaction. Are you getting it now? Irreversible, it cannot be reversed. Okay, but the fourth reaction is what gets to completion, but the reverse reaction, it will not occur. So take note of this. Okay, let me, which one again? Let me cancel this. So look at this ways. Look at this ways by which a product is being removed from a reaction. How can a product be removed from a reaction? So number one, when it is insoluble and precipitate out of the solution. I've told you because when it is insoluble, meaning it cannot react. Yes, it cannot react when it is insoluble, because you must at least, when a reaction occurs, all the two reactants must be soluble. They must come together. They must come. Let me say, when you are, all these people that are molding block, let me say block let me say mud, all these people that are using mud to manufacture all these pots, you know, those type of mud, they are what, they let me say, a form of, they react with other chemicals, but in a situation where the mud is very strong, they will remove it. That's why they will what, soften it with water. Are you getting it now? So meaning, when number one is what, when it is insoluble. When it is insoluble, meaning it cannot react. It cannot react. So it will what, go out from the, or it will escape from the reaction. That is how most of the products are escaping or are being what, removed from a chemical reaction. So ways by which products are removed: number one, when it is insoluble and precipitate out of the solution. Number two, when it is unionized or polyionized and so cannot participate in the reaction. When it is polyionized, it cannot ionize or more hunger. So when it is unionized or polyionized and so you cannot participate in the reaction. So take note. Number three, when it is a gas and so escape from the reaction system. So please take note of all of them. When it is a gas, it will what, it will just what, escape from the what, from the reaction system. Okay, so take note of all these things. Take note of them. Let's continue. Okay, let's look at this one, which is thermal dissociation. It means that each molecule of a substance dissociates into two or more simpler molecules or atoms on the application of heat. Dissociate. I get it. The word dissociate means something that can be at least, or let's say each molecule of a substance dissociate into two or more. It's just in form of splitting. I get it. Splitting, like differentiating itself, dissociating. Are you getting it now? So look at it. Thermal decomposition is irreversible, while thermal dissociation is reversible. So are you seeing it now? What did I say about thermal decomposition? I said when it is applied to a reaction, isn't it? That is what I said. It is called what, thermal decomposition. Meaning, so it means that thermal decomposition is irreversible, while thermal dissociation is reversible. So this is a key difference between thermal dissociation and thermal decomposition. Thermal decomposition is irreversible, while thermal dissociation is reversible. So this ammonium chloride, heat, cold, okay, bottom of 2R, okay, it will reverse when cool. Okay, let us continue. Okay, so the last one, which is oxidation reduction reaction. This is the last one, oxidation reduction reaction. We cannot define oxidation reduction just like that, because it is vast. Let me say is versatile, meaning that it's very broad. I get it, because it has a lot of explanation. Okay, let's look at the first one, which is they are abbreviated by redox reaction. So meaning that when you hear the word redox reaction, it is talking about oxidation reduction. They combine them together to form this single word, which is called redox reaction. Are you getting it now? So oxidation reaction, you can call it what? Redox reaction, because this oxidation reduction is too long. Are you getting it down? So just call it redox reaction. Once you call redox reaction, a chemistry student will understand that you are calling oxidation reduction reaction. So take note. Okay, let's go to the second one. Oxidation reaction, which is addition of oxygen, meaning that, okay, oxidation means addition of oxygen. Write it down. Oxidation means addition of oxygen. Why? The donor of oxygen is called the oxidizing agent. Just write it down, I will explain. Okay, so oxidation means what? Addition of oxygen. Also, the donor, meaning the particular element that is donating the oxygen, is called the oxidizing agent. Then reduction reaction means removal of oxygen. I get it now. Oxidation means what? Addition of oxygen. Reduction means what? Removal of oxygen. So why the acceptor of oxygen is called the reducing agent? Oxidation means what? Addition of oxygen. The donor of the, let me say, the element that is donating the oxygen is called the oxidizing agent. While reduction means what? Removal of oxygen. And the element or the compound that is accepting the oxygen is called the reducing agent. Reducing agent. Okay, so let's continue. So look at the example now. So look at this example. Look at it. Look at this example now. E.g., copper. I say copper. Carbon is reacting with zinc oxide. So which one is the, if you see this type of question in your Jamb and they said identify the oxidizing agent and the reducing agent, from this definition, look at it here. From this one, I said what? Oxidizing agent is the what? The donor, isn't it? The one that is donating the oxygen, isn't it? So here the oxidizing agent is what? Is the zinc. Well, look at this one. This one is carbon. It does not have oxygen. But this one, zinc oxide, it have what? Oxygen. So meaning that zinc oxide are what? Donated oxygen to this carbon. So it is now what? Carbon 4 oxide. Here is R. Okay, it is now what? Carbon 4 oxide. Let me draw this single arrow. Oh, let me just wait, I'm coming. Okay, so look at it now. Are you getting it now? So meaning carbon has no oxygen, isn't it? Carbon has no what? Oxygen. Carbon has no oxygen, but I'm trying to draw something. Carbon has no oxygen. Yes, zinc oxide has oxygen. So meaning I said oxidizing agent, the donor of oxygen is called the oxidizing agent. So here the zinc oxide is the oxidizing agent. I get it now. Zinc oxide is the what? Oxidizing agent. Why this one? Remove the acceptor. This is the acceptor. It got accepted oxygen from here. So the carbon is now what? Carbon and here. Carbon is now the what? Reducing agent. I get it now. It reduced this one to a single zinc. So carbon here is a reducing agent, while zinc oxide is the oxidizing agent from this definition. Okay, so let's continue. So the second one, the oxidize, under definition again, the oxidizing agent zinc. Okay, yes, the oxidizing agent zinc oxide donates oxygen. I get it now. The oxidizing agent zinc oxide donates oxygen to the carbon and oxidizes it to carbon 4 oxide. The reducing agent, which is the carbon, removes oxygen from zinc oxide and reduces it to a metallic zinc. So are you getting it now? So this is how to identify oxidizing agents and reducing agents in a chemical reaction. So make sure you write everything down, rewatch the video. If you like sleep, na you sabi. So another definition again, I'm coming. Okay, so second way to identify an oxidizing agent and reducing agent, the second one is removal of the aspect of removal of hydrogen. Look at it. Oxidation, removal of hydrogen. Reduction, addition of hydrogen. Are you seeing it now? Oxidation oxidation, removal of what? Hydrogen, while reduction, addition of hydrogen. Let's continue. Okay, we have passed here. Okay, look at it now. Look at this this thing. Electronegativity decreases and electropositivity increases. You can see this question in Jamb because decreasing and I think when we come to periodic table, you will see all these things. Okay, so electronegativity, meaning that, let me look at this. This one is what? Electronegativity decreases, meaning this one is from the highest to the what? Lowest, meaning all these ones are electronegative elements. Okay, negative. Okay, so meaning fluorine is more electronegative than oxygen. Oxygen is more electronegative than chlorine. Chlorine is more electronegative than nitrogen. Nitrogen is more than bromine. Bromine is more than carbon. Carbon is more than iodine. Iodine is more than this thing, phosphorus. I get it now. So it is what? Decreasing. It is decreasing from the top to the bottom. So this is the correct way. So in Jamb, they will just mix everything. I get it. They will just say, what is the correct electronegative decrease? I get it now. They will just set the question in that form. Then they will just sometimes they will put nitrogen at first in a particular option. Let's say option A, they will just put nitrogen. Not that they will put all these ones, so they will just, let me say, start from one that is FOClN and BR. They will just stop, but just know that fluorine is the first one, oxygen is the second one, chlorine is the second one, nitrogen is the second one, bromine is the second one. They might just start from here. I get me. But if they want to confuse you, they will just mix everything. I get it now. They will just sometimes they will just ask the question, what is the correct order of electronegative decrease? I get it now. So just know that if you didn't see F, just know that oxygen is the second highest. If you didn't see but just know this main format. Are you getting it? So know them. Then electropositive increase. These are the positive ones. Potassium is increase. So potassium, meaning that potassium is the smallest one here because it is increasing. Are you getting now? So meaning that copper is the highest. Are you getting now? Copper is the highest. So if it happened that they turn around the question, around, they will just write the correct order of electropositive decrease. I get it now. Decrease, they will start from carbon or lead or iron or zinc. But this one, it is what? Increasing, so it is starting from the smallest one. This is the less electropositive. It is less electropositive than sodium. Sodium is less electropositive than calcium, magnesium, aluminum, zinc, iron, lead, and copper. So take note of them. Okay, take note of them. It's very important. Take note of them. It's very important. Okay. Let's go to the last one. Okay, look at this. A substance loses electrons when it is oxidized and gains electrons when it is reduced. An oxidizing agent is a substance which accepts electrons. It reducing the reducing agent is a substance which donates electron. Okay, just remove this thing. Okay, remove it. Okay, meaning reducing agent is a substance which donates electron. So we have come to the end of this is on the end of this topic. There is a particular calculation how to calculate oxidation number. Okay, I will record that video then drop. Okay, but this one is very, at least make sure you study this topic very well. Okay, study this topic very, it's not easy, so you have to try your best. Okay, you have to try your best. So I will show you in another video. It might be in video format or we do it handwritten, because I said it's not every time I'll be recording video. Are you getting it? So it's not easy. The stretch is not easy. So we might do it anyway. But that is the last part. I will show you how to calculate oxidation numbers. Okay. So this is the end of this topic. So make sure you have. If you have any question, we can answer together in the interacting group. Okay. Okay. Bye. Make sure you study.